Good morning, all. Welcome. This is the best session of the day, and we have some of the best speakers here. So it's the first session, okay, and this is the first talk. And typically, the first talk is either the best or the worst. The best to get people in, the worst because no one's going to come in anyway. So, anyhow, my name is Kishan Shenoi. I'm with Intel. And this particular talk, though, is on behalf of the ITU Study Group 15, Question 13, which deals with standards, specifically standards related to sync and timing. So my two co-authors are the rapporteur and associate rapporteur of Question 13. That's Stefano Ruffini, who's with Calnex, and Silvana Rodriguez, who's with Huawei. They could not make it, but I've known them for many, many years. I've been involved with Question 13 for over 20. So have they. So what am I going to talk about? Some of the importance, value of the industry for having something standardized and how that can help, which is probably mother's milk, and everyone knows that. The more important things come later. How can OCP TAP take advantage of the work done in Study Group 15, Question 13, provide an overview of the standards body, and go a little deeper into the standards that could apply, or what standards can be developed. So why develop standards, mother's milk? It's standardized solutions, if you get down to it reduces the total cost of ownership for both vendors and users. It kind of makes sure things interwork, and if you have met a standard, there's a good chance that what you have designed will meet the needs of the application that you intend to use it in. For an example where OCP TAP is involved is in data centers. One of the important things we're finding is that it's incredibly important. Timing is important, and there was a study which was described last year in the summit, which basically says that synchronized decisions decrease power, decrease delay, and generally improve the quality of experience. The timing requirements, however, how stringent they are, they used to be in the order of seconds, then milliseconds, and now it's at the microsecond and getting more stringent. Now, in a data center, you have so many different servers. How do you kind of get them all aligned in time? The approach taken, or approach suggested, is to have a source of time in the data center called a PTP Grandmaster, and use PTP, which is the Precision Timing Protocol, also affectionately known as 1588, to get timing from the Grandmaster to the equipment clocks. The standard which has been promulgated so far requires that, or suggests that the maximum time error between any two equipment clocks or ordinary clocks be less than 5 microseconds, between the Grandmaster and the equipment be 2.5 microseconds, and if there are any devices in the path of the timing between the Grandmaster and the endpoint, they should be transparent clocks capable of supporting timing to better than 100 nanoseconds. How about between data centers? Yet to be determined. So what is Study Group 15? Just a shout out to them. They deal with network transport, home networking, optical technology, and Question 13 in particular in there deals with sync and timing. Shout out again to Study Group 15. It's the most productive of all the ITU study groups. By the way, how many of you know what ITU is? Since I can't see anything because of the lights, I'm assuming everyone does. It's the International Telecom Union. It's a division or a branch or a subdivision of the United Nations. Now, why is this stuck? Every time I say something stupid, it sticks.
It's stuck. You have a clicker?
Let's try this. Yeah. No, it's on that side.
USB?
USB, single USB is here.
Oh, wow.
Yeah,
Let's see if that gets the job done. I don't have a copy of the presentation. So.
Oh,
does that work?
oh, something happened. Yeah, good.
So which one are we?
Okay, yeah, thank you. So what, so question 13, we deal with timing. So it's a group which has been active since the 90s and emerged when, the emergence of Sonnet and SDH, that's when it became really, famous because it developed all the standards required for that. Since then, it has progressed. Now we deal a lot with time phase and frequency and distribution and clocks associated with packet networks. We do have a lot of cooperation with other questions in study group 15. By the way, why is it called a question? No one really knows, but in the ITU, each different group was handling one question at that time, and the convention stuck. So what are the outputs from question 13? Basically documents. And they're basically standards dealing with a wide variety of applications and scenarios. The standards typically will be called a G dot with a number. And that's a holdover from previous days. The earlier standards were like the G803, 810, 811, etc., but developed quite some time back when the network was fully TDM. Since the network is emerging as being primarily packet-based or Ethernet-based, the 826 series, 826X series arose dealing with delivery of frequency synchronization. The 827X series deals with time. So I've put it in bold because the OCP TAP is very focused on time. It develops a bunch of supplements like 65, which is simulations on timing support, and another technical report dealing with the use of GNSS. Just to give you an idea of one of the documents, 8275.1, rolls off the tongue very nicely. It is a PTP profile for use in the telecom network, which has full timing support. And by that we mean that timing originates from a PRTC, or primary reference time clock, or a TGM, which is a telecom grandmaster, meaning PTP, and is delivered over the network, and every device in between is either a boundary clock or a transparent clock till it reaches the end equipment, where it's usually a subordinate clock. And the other standards support the behavior of all these different individual entities. I'll just skip over this one. It's an example of how we address, and analyzing a full timing support. You have to have an idea what each individual device in the path, how it transfers any input noise to the output, and how much noise does it generate by itself. And so you can build up a chain and see how the noise, timing noise, accumulates. And here's an example of the budgeting. This one comes out from wireless, where you require that at the very end point, the antenna of the wireless base station relative to the world standard has to be within 1.5 microseconds. So how can you do that? And you have a chain of equipment, and then you can see how it is allocated. This noise budget is allocated to the different parts of the network. G.8275.2 is another profile, but this goes one step further than .1, because it allows the network to include devices which are PTP unaware. The issue with a device being PTP unaware is that the timing packets which are delivered can experience significant packet delay variation. So you have to deal with it. And packet delay variation is the enemy of time transfer. There are two aspects to 8275.2. It assumes that in the case of APTS, or Assisted Partial Timing Support, there is a local time source closer to the endpoint, which is typically GNSS or GPS based, and it uses that as the timing, but uses the network and PTP as a backup. Partial timing support by itself means that the network is the conduit for delivering timing. Some of the ongoing studies we have, of course, we're always looking at the new profiles, if any, and that's where OCP TAP may be able to kind of collaborate or contribute to the question 13. Specifically, OCP TAP has kind of promulgated a profile. Profile is just a way of using PTP, which is simplified. And it's simplified and to some extent makes it easy to use, makes it quick. I hate to use the phrase quick and dirty, but it is quick and not so dirty. Okay. It's similar to 8275.1. It's got some aspects of 8275.2. So if we ever develop an ITU profile, we'll probably call it 8275.3 and see what can be reused and what new stuff has to be added in. Going forward in Q13, the bunch of items that we are working on, and what I've highlighted or put in bold, are some which are more particularly appropriate for OCP TAP. The notion of network management and monitoring, security, and synchronization associated in many forms regarding data centers. So the call for action, like I said, I'm representing Q13 here, and what we are looking for is more people to contribute. It is a standards body, but every standard is based on contributions from the members. It is not created out of thin air. So in order to develop these standards, we need contributions. And the areas where Q13 can help the standardization process appropriate for OCP is, well, I've given a list of things that can happen, such as end-to-end network requirements, a new profile associated with OCP TAP, the notion of HRM, which is a very ITU term. It stands for Hypothetical Reference Networks. So that's the kind of typical network you think of when you do an analysis. There are different kinds of clocks, those clocks which are good for full timing support, those which are good for partial timing support, assisted partial timing support, etc. And last but not least, testing guidelines. How can you verify that a piece of equipment actually is going to meet its requirements? So like I said, it is a contributive scenario, but you have to be a member of ITU in order to do that. And here's how do you become a member. There's a link. You go to ITU, UN Tech Agency, and it's, I think most companies who are attending OCP are likely to be members of ITU, so please contribute. I've mentioned the contacts for Q13 in particular. There's Silvana Rodriguez. I'm reading from bottom up. Silvana Rodriguez, Stefano Ruffini, and Hiroshi Ota is the study group 15 advisor. But for timing and sync, Q13 is the place to be. Thank you. And any questions, I'll take them now, or you can grab me in the hallway or anytime. And am I on time? Yes. Okay, good. Thank you.